Good morning. Today we'll discuss some examples on the inverse Laplace transform. Of x of s is equal to 3s plus 2 over s square plus 4s plus 5. Okay, so this is the example given to you, and we have to find the this is the quadratic equations, and we can write this like this: s square plus 4s plus this 5, we can write 4 plus 1, and therefore this we can write here in the standard form of s plus. This is the perfect square, s plus 2 square, this s square plus 2 into 2, 4s plus 4 square, that is 4 plus 1. Okay, so instead of this we can write such type of the factors, and therefore we can write here x of s is equal to, in the denominator, s plus 2 square plus 1, and then in the numerator there is a 3s plus 2, so we can add here 6 and also subtract 6, so the equation will remain same. So we can take here 3 outside, so what will remain here is plus 2, and what will remain there 4. So these factors we can write here, this simplification is plus 2 minus 4. Okay, so this is the function having the complex conjugate poles. That's why we have to use these methods, and therefore we can write here x of s is equal to 3 into s plus 2 over s plus 2 square plus 1 minus, here we can take here 4 like this, and we can also write 1 over s plus 2 square plus 1. Okay, now we have brought this into the standard form, and now we can take the Laplace inverse transform. Take Laplace inverse transform of above equation. So its inverse Laplace transform will be x of t, and therefore this will be the 3, and this is the standard form, that is a cos t. Therefore this is a e raised to power minus 2 t into cos of t into u of t minus this second factor 4 into, this is also in standard form, so therefore e raised to power minus 2t into sine of t into u of t. So this is the inverse Laplace transform of the given function. Inverse Laplace transform of the given function. Okay, next example we will consider example number 2. So x of s is equal to s square plus s minus 2 over s cube plus 3s square plus 5s plus 3. Now this is, we can say this is the transfer function, and here the this equation is having the complex conjugate poles. First we have to find the factor of this, and therefore their solution lies in the trial and error methods, as there are the three poles are there for this equation, as the order of this equation is 3. Therefore we will put here, suppose this is the s plus 1 into s square plus 2s plus 3. So this equation, above this equation we can write like this. If you solve these two factors, you will get the same equation. So this is s cube plus 2s square plus 3s plus s square plus 2s plus 3. So here we are getting here s cube plus this 3s square plus this 5s and plus 3. So this means we are getting the same equation. So instead of this equation, we can write this factor s plus 1 into the bracket a square plus 2s plus 3. And this is a quadratic equation, and we can find the roots of the quadratic equation by using the quadratic equation. So we can write here x of s is equal to s square plus s minus 2 over s plus 1, and instead of this factor, this factor s square plus 2s plus 3, this is a quadratic equation. We can find the roots of this minus b plus minus b square, that is a 4 minus 4ac divided by 2. Okay, so this is coming minus 2 plus minus 4 minus 8 minus 8 by 2 minus 2 plus minus, so we will get here minus 2 plus minus, so it is minus 1 plus minus j root 2. Okay, so there are this is the complex conjugate force at s is equal to minus plus minus j root 2. Okay, so we can write here this factor. Instead of this factor, we can write here s plus 1 square plus root 2 square. So instead of this, we can write like this. So once you get, now we can expand this A over S plus 1, and this is B1 of S plus B2. This is plus 1 square plus root 2 square. So we have to find these values. And therefore this A values can be found. S plus 1 into x of s at s is equal to minus 1. So s plus 1, what is x of s? X of s is s square plus s minus 2 divided by s plus 1, s square plus 2s plus 3 at s is equal to minus 1. So this will get cancelled. 1 plus 1 minus 2. This is minus sign. This is equal to minus 1. So minus 1 divided by 1 minus 2 plus 3. So this value is coming here, minus 2 over minus 2. Maybe it is plus 2. So it is minus 1. And this is value of A. So A is minus 1. Now find the other values. So how we can find the other values? We have to just remaining coefficient. This is a B1 and B2. We have to obtain by placing both the terms on the right hand side of this equation, okay, over the common denominator and equate the numerator of the results to the numerator of x of s. Okay, so here we have to make the common denominator on the both the sides, and then we have to equate the numerator of the both sides of these equations. Therefore I am, so x of s is here, x of s is s square plus s minus 2 over s plus 1 s square plus 2s plus 3, and on the right hand side we have the minus 1 into s plus 1 square plus root 2 square. Root 2 square plus b1 s plus b2 into, so what was there in this side? On this side it is a s plus 1 so this is s plus 1 square. So what will appear here in the okay there it is s plus 1 is there. So s plus 1 and for making the denominator common we have to again put here here s plus 1 s plus 1 square plus root 2 square. Okay, and what will be initially this term was there, this term is not there, so for we have to multiplied the numerator also s plus 1. Here we have multiplied s plus 1 to make the common denominator because there was only this term, and now to make the common denominator we have multiplied the denominator also s plus 1. Now the denominator is same. Okay, denominator on the both the sides is same, so we can equate the numerator of both the sides. Okay, this is s square plus 2s plus 3, we can also write like this. So s square plus s minus 2 is equal to minus 1. This is s square plus 2s plus 1, and square root of square is here 2 plus here it is a, we'll solve this b1s, this is b1 square, b1 square, b1s plus b2s plus b2. Okay, now we have to solve this further. Minus 1 s square s square. So here it is a 1 plus b1 s square, or we'll solve this negative sign. First we'll solve this for the negative sign. Minus s square minus 2s minus 1 minus 2, whereas the rest of the sign will be same. S square plus s minus 2. Now we have to equate the s terms. So s term, this is s square minus s square plus b1 s square. So here 1 is equal to minus 1 plus b1, and therefore b is equal to 1 plus 1 is equal to 2. So what is the value of b1? It is b1. So what is the value of b1? It is a 2. Now we have to find the value of b2. For that we can just compare this constant also. The constant on this side is b2 and constant on this side is 2, and therefore bt is equal to minus 2. Now one more constant is here, minus 3. Okay, sorry. Minus 2 on this side constant is this minus 3 plus b2. So b2 is equal to minus 2 plus 3, that is equal to 1. So that is b2. b2 is here 1, or we can also find by equating the yes coefficient. Yes coefficient is there on the left side. Yes coefficient is also on the right side. And if you find b2, from that you will also get the b2 is equal to 1. Okay. So here we have got b1 is equal to 2 and b2 is equal to 1. Now we'll put this into the given equation, this equation, as we have found now a1, b1 and b2. We have found all these values and we have to put these values in this equation now. Therefore, x of s is equal to pq value is -1, value of e is, and this is s plus 1 plus what is the b1? b1 is 2, yes, plus b2, it is 1 divided by s plus 1 square plus root 2 square. Okay. Now we can separate these terms further. -1 over s plus 1 plus instead of this 2s 2s plus 1, we can add here 2 and we can subtract here 2. Okay, so there from this we can take here 2 outside. So what will there? S plus 1 and this is a -1. Okay, so instead of this 2 s plus 1 we can write this factor. Okay, so I can write here 2s plus 1 minus 1 divided by s plus 1 square plus square root of, like this. So further I can write here, separate these terms, 1 over s plus 1 plus 2 into s plus 1. I am putting this into the standard form, s plus 1 square plus root 2 square, and this is a minus 1. I can take a sign is -1 here. So I will put this into the standard form. What standard form? S plus 1 square and square root of 2 square. Okay. So what term is there? -1. So one term is here, but we are for putting the standard form, we should have the root 2 here in the numerator. And when you multiply this by root 2, we have to also multiply by this whole factor by this factor. Okay, as we have multiplied and divided by the same factor, so again it will remain the same, but this will put into the standard form. Okay, this will put into the standard form. So now our problem is solved now. Okay, now we have to just find the inverse Laplace transform of this equation. Taking inverse Laplace transform of above equation, therefore inverse Laplace transform of this is x of t. Here inverse Laplace transform is minus sign e raised to power minus t into u of t plus here it is a 2 e raised to power minus t cos of root 2 t into u of t plus the integration of this third factor minus 1 over root 2 into e raised to power minus t into sine of root 2 t into u of. Okay. This is the inverse Laplace transform of this given transfer function. Okay, I think this much is sufficient. Remaining we'll discuss in the next lectures. Thank you very much.